Welcome to this quick and powerful revision session for ICSE Class 10 Physics. In this video, we will revise some of the most important concepts, definitions, and formulas that frequently appear in board examinations. Think of this as studying together using topper-style handwritten notes. So relax, stay focused, and let's begin our revision. Let's start with the concept of force and moments. When a force causes an object to rotate around a fixed point, it produces a turning effect, known as the moment of force. The moment of force depends mainly on two factors: the magnitude of the force applied and the perpendicular distance of that force from the pivot or axis of rotation. An important rule related to this is the principle of moments. According to this principle, for a body to be in equilibrium, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. This principle explains how objects remain balanced, such as a seesaw or a wrench turning a bolt. It is also important to remember the difference between static equilibrium and dynamic equilibrium. Static equilibrium occurs when the object is at rest, while dynamic equilibrium occurs when the object moves with constant velocity. Now let's move to work, energy, and power. Work is said to be done when a force causes displacement in the direction of that force. Mathematically, work is expressed as W equals F multiplied by S multiplied by cosine theta. This shows that work depends on three factors: the force applied, the displacement produced, and the angle between the force and displacement. The SI unit of work is the joule. 1 joule is equal to 1 Newton meter. Next comes power, which tells us how quickly work is done. Power is calculated as work divided by time. The unit of power is the watt, where 1 watt equals 1 joule per second. Another important concept here is the work-energy theorem. It states that the work done on an object is equal to the increase in its kinetic energy. Kinetic energy depends on the mass of the object and the square of its velocity, while potential energy depends on mass, gravitational acceleration, and height. Now let's talk about machines. Machines help us perform work more easily by multiplying force or increasing speed. A very common type of simple machine is the lever. Levers are classified into three types based on the positions of the fulcrum, load, and effort. In a Class 1 lever, the fulcrum lies between the effort and the load. Examples include scissors and a seesaw. In a Class 2 lever, the load lies between the fulcrum and the effort. A wheelbarrow is a good example. In a Class 3 lever, the effort lies between the fulcrum and the load. Tweezers are an example of this type. Another important machine is the pulley. A single fixed pulley only changes the direction of force and has a mechanical advantage of 1. A single movable pulley reduces the effort required by half and has a mechanical advantage of 2. In real machines, efficiency is always less than 100%. This is mainly due to friction and the weight of moving parts. Now let's revise refraction of light. Refraction occurs when light passes from one medium to another and changes its direction. This bending of light happens because the speed of light changes when it enters a different medium. The relationship between the angles of incidence and refraction is described by Snell's law. The refractive index of a medium depends mainly on its optical density, temperature, and the wavelength of light. Another interesting phenomenon related to refraction is total internal reflection. This occurs only when light travels from a denser medium to a rarer medium and the angle of incidence becomes greater than the critical angle. Now let's understand lenses. A convex lens converges parallel light rays and forms a real focus. A concave lens diverges light rays and forms a virtual focus. Ray diagrams of these lenses are extremely important for board examinations and must be practiced carefully. Next, let's move to sound. Sound waves are longitudinal waves, and they require a material medium for propagation. One interesting phenomenon related to sound is the echo. An echo is heard when sound reflects from a distant surface and returns to the listener after the original sound. The distance of the reflecting surface can be calculated using the formula distance equals velocity multiplied by time divided by 2. Another important concept is resonance. Resonance occurs when the frequency of an external force becomes equal to the natural frequency of a vibrating body. At resonance, the amplitude of vibration increases significantly. Also remember that the loudness of sound depends on the square of the amplitude of vibration. Now let's move to electricity. One of the most fundamental principles here is Ohm's law. According to Ohm's law, if the temperature remains constant, the potential difference across a conductor is directly proportional to the current flowing through it. Mathematically, this relationship is written as V equals I multiplied by R. Resistance of a conductor depends on several factors. It increases with the length of the conductor and also increases with temperature. However, it decreases when the thickness or cross-sectional area of the conductor increases. The resistance also depends on the material of the conductor. It is also important to understand the difference between electromotive force and terminal voltage. Electromotive force, or EMF, is the potential difference of a cell when it is not supplying current. Terminal voltage is the potential difference measured when the cell is actually in use. Now let's understand electromagnetism. Electromagnetism explains the relationship between electricity and magnetism. Two important rules help us determine directions in electromagnetic systems. Fleming's left-hand rule is used in electric motors to determine the direction of force. Fleming's right-hand rule is used in generators to determine the direction of induced current. Another important device is the transformer. A transformer works on the principle of electromagnetic induction and is used to change alternating current voltage. A step-up transformer increases voltage because the secondary coil has more turns. A step-down transformer decreases voltage because the secondary coil has fewer turns. The strength of the magnetic field produced in a solenoid depends on the current flowing through the coil and the number of turns in the coil. Finally, let's revise calorimetry and radioactivity. Calorimetry based on the law of conservation of energy. According to this law, the heat lost by one body must be equal to the heat gained by another body. The heat energy involved in a change in temperature is calculated using the formula Q equals M multiplied by C multiplied by change in temperature. Specific heat capacity refers to the heat required to raise the temperature of 1 unit mass of a substance by 1 degree Celsius. In contrast, heat capacity refers to the heat required to raise the temperature of the entire body by 1 degree Celsius. Radioactivity is a spontaneous nuclear process in which unstable atomic nuclei emit radiation. There are 3 main types of radiation: alpha particles, beta particles, and gamma rays. 2 important nuclear reactions are also studied in physics. Nuclear fission involves the splitting of a heavy nucleus into smaller nuclei. Nuclear fusion involves the combination of light nuclei to form a heavier nucleus and releases an enormous amount of energy. Before your exam, it is helpful to connect all these concepts using visual summaries and mind maps. This helps you link formulas, definitions, and applications together. Physics becomes much easier when you understand how these ideas are connected. Keep revising regularly, practice numerical problems, and stay confident. Good luck for your exams. You've got this.